All right, hello everyone. Can everybody hear me? Sorry about that. Okay, we're back. Sorry about that. Um, okay, finally. Yeah, sorry about that. I had a work-related issue come up. It was promised that it would take 5 minutes. It took much longer than 5 minutes. Um, so today I'm just going to be just one more time. Let me just get a confirmation in the chat of who's here. Essentially a roll call. That it would take 5 minutes. Is anybody here? I'm sorry, everyone. I've failed everyone. Uh, but hopefully some people come back to the stream. Because I think this one's actually really useful. Not that everything
It would take 5 minutes.
Isn't useful per se, but it is. I think this topic is pretty useful. Okay, cool. So it looks like everybody is here. So we can get started. So today, okay, everybody's here. Awesome. Um, all the cool kids are here. We're just going to do an introduction to Git and Linux. So Git is a version control system, and Linux is just a type of like operating system. But you'll find that a lot of developers end up using like a Linux-based terminal for their work. Um, it's it's pretty. I think it's pretty useful. Once I learned it, I haven't really wanted to use anything else. So first, I'm just going to give you a very, very quick introduction to the Linux terminals. So hopefully everybody got Ubuntu installed or is already on a Mac. But if you're on Windows, either like a application like Cygwin works, and then something like, or just you can also download an Ubuntu distribution and then enable that. That one takes a few more steps, I think, but hopefully everybody has access to some sort of terminal environment. So I'm just going to go over a few commands. These are going to be the ones that are important when you're setting up your GitHub repository, and both remotely and locally. So the first thing I'm going to show you is just mkdir, which is just make dir, which is make directory. So let me pull up a terminal window, and I can show you what that looks like. Okay, so I have the directory I'm currently in. You can type pwd and see like what directory you're in. So right now I'm in users, c /teaching. So if I want to make a new directory, let's say, in the PowerPoint, the formatting got weird. So, okay, that's what it should look like. So if I pull up my terminal again, we can say make dir Linux tutorial. So when we do that, we can type ls. ls will show us the current visible contents of our directory. If you do ls -a, it will also show you hidden files. And right now we don't have any hidden files, but if we did, like, they would show up if we did ls -a. So we have that directory Linux tutorial. So if we want to change our directory into Linux tutorial, we can just say cd Linux tutorial. So cd is just change directory. It just changes your current working directory to whatever you type as an argument after cd. And you, so I can't just cd into anything. Like the terminal has to have knowledge of the working directory, and whatever we're changing the directory to, it has to be visible to the current working directory. So we're inside Linux tutorial. So pwd. Now we're inside Linux tutorial. Let's say we just want to make a few more folders. We can do it like this. We could say make dir folder 1, folder 2, folder 3. And now if we ls, we'll see that those directories have actually been created. So obviously if we go into one of them, like folder 1, there's not going to be anything in there. So, and if we do cd ... we'll go back out to our previous folder, which is Linux tutorial, which has folder 1, folder 2, folder 3. So let's look at how to create some folders and files just from the command line, which can actually be fairly useful from time to time. So if I want to just make a new file, I could say something like touch sometext.txt. And when I do that, it creates an empty file called sometext.txt. So let's say I just want to type in a message into it. I could say hello. I would say echo hello, which, by the way, by itself, just... Actually, I don't quite know what happened there, but here, this should work. So what we can do is we can say echo and then hello in that string, and then a arrow like this, and then some text.txt. Okay, I don't actually know what's going on there. There's some actual weird stuff happening. What we can do instead is just be brave and use Vim. So if we type vim some text.txt, so Vim is a text editor that's it might look rather primitive to you, but in terms of its functionality, it's actually considerably more functional than something like Microsoft Word if you know what you're doing and all you're doing is doing text editing. So if we do vim some text.txt, you'll see this open. So what we can do is we can press I, which puts us in insert mode, and we can say, hello world, my name is Chris. And then if you press the escape key, we will open the command line again, and then type :WQ. And that essentially that writes whatever we just wrote in this file to the file, and then Q quits. So now we can do another command called cat, and cat will print all the contents of the file. So if we do cat some text.txt, we'll see what we just wrote. I'm actually genuinely confused about the echo thing. I've never actually seen that before, so whoops. But Vim works fine. I usually do text editing in Vim. I usually don't echo things to a file. I usually find it like it's just less work to just Vim most of the time. So let's move on. So let's just talk about Git now. So that was a real crash course into the Linux command line. And if you want me to go over any of it again, let me know, because I'm kind of just showing you the commands without really showing you the concepts behind it. But I just wanted to give you enough Linux so that you could reliably do the Git stuff that we're going to do today. So Git is a version control system, and it's not the only version control system. There's other stuff like Mercurial or... actually, I don't even think I can really name another one because I don't really ever see them get used. And the only version control system I have any clue how to use is Git, and I always feel like I'm learning new things with Git anyway. So I don't even know if I could, like... I wouldn't even know where to begin with other version control systems. I imagine that they're pretty similar, though. And version control, what it lets you do is it lets you create multiple software versions, and it also allows multiple developers to work together at the same time. So, for example, if I had 5 people and we were all working on a project, I mean, that's actually pretty much what my job is. I work on a team, and we have several packages that we, different permutations of us shared. Like have shared packages, and we work on the same stuff all the time. But it would be really bad if I put up a new feature and then somebody else puts up a new feature right on top of it, because we're not actually testing to see if those two things go together. Because a lot of times you could put something in code and put another thing in the same code base, and then individually they would both work, but when you have them together in the same package, they can cause problems without integration testing. So version control is super important for that. And also, like, if I make a mistake, like, which happens, like I'll, there was actually kind of a funny one where, it happened yesterday, in fact, where, somebody basically had a function with like parameters A and B, and in the code, they sent the arguments f of b, comma a. And we were wondering why a particular service wasn't like running the way we would expect. So in that case, you can either just put a commit on top of it, you can change it, or you can revert the code that you made and just go back to your previous commit. So if some of that stuff seems pretty abstract, it's because it's really abstract. Like there are a lot of developers that still struggle with Git, even experienced developers. Like I said, I learn new things all the time. But you do not want to code without some sort of version control system. If you do, you're kind of asking for trouble. I've had enough incidences of not using good version control and having that bite me. So we're going to be using GitHub because it's a free version control platform, and honestly, it's pretty good. There are other version control platforms. There's one called Atlassian that I've used before. I had a friend that really liked to use Atlassian, so we just used that when we made projects. But I think you'll find that most developers end up using GitHub. That's more or less the industry standard. And you can make a free account. It's pretty sweet. It's pretty functional. So yeah, we're going to be doing that in a second. So one of the basic some of the basic ideas in Git are essentially you have a working directory, which is where you're making your current changes. So it's like your current code base, and then you're just typing and you're testing and whatever. You can, and then when you say, okay, that's good, I'm ready to like put this up, you add it to the staging area. And then when you add it to the staging area, you can commit it. And when you commit it, it moves the code that was in your staging area to a local Git repository. And then from that local Git repository, you can push it remotely if you want to use a remote GitHub repository, or not a GitHub, but any Git repository, any remote Git repository. But also, if you're just coding by yourself, there's no problem with just having a local repo, and all you really do is add and commit, and then that's all you do. That's perfectly reasonable too. There are a lot of use cases for Git. So Git is based on trees, and each of these trees, each of these nodes in the tree represent a different commit. And then essentially what you do is you start with the same code base, and then you make a change. Here's another commit, and then maybe you're testing a new feature. Like you branch off, like this is called branching, and you would branch off and start testing a new feature over here. So now feature A is here. But then another developer you're working with on the same package decides to go, they have something else that they made. So they put a commit on top of this commit. And then basically everybody starts like diverging and working on their own thing. So then maybe there's a bug here. And then we made a couple commits here. We realized there's a bug related to code here. So we go back here, we branch off, make a bug fix, and then eventually everybody will merge their branches together. And then like this master node here represents the topmost commit. Usually your master branch is the one that's considered kind of like your true branch. So if somebody was going to look at your code and pull down your code, they would want to probably pull down the master branch. But developers working on it will branch off from that master branch, and then eventually merge their changes into the master branch once they have tested it, which usually involves pulling down the most recent commit on the master branch and then putting your changes on top of that commit on the master branch. If you're confused, don't worry about it. We'll figure it out. And essentially, just kind of to give you a definition, commit holds the current state of the repository. You have you have your working directory. You can add stuff to your staging area from the working directory, which is just kind of the middleman between what you're currently working on and then the local Git repository. And then, so my point was that, so basically your local repository says this is what the current state of your code base is. And then if you want to, you can push it to a remote GitHub repository or something like that. Just any remote Git repository. So in this case, maybe we start off at C0. We make a commit, we get C1, C2. Another developer starts working on the same code base, so they pull some change. They pull the current code base down, and then they make their own commit C3. But then we're still working on this code base here, C2. So we put our changes C4 on top of C2. And then maybe I make another change, C6. The other developer keeps working, C5. And then the other developer can then take these changes in C6, merge those changes on top of C5 to make sure that their changes work with my current code, and then they can push that and merge these, or they can merge these branches and then push that branch. And then there's a concept called head, and basically head's a pointer, and it always points to the latest commit on the branch. So whenever you would make a commit on a branch, head becomes that commit. So it's just like an alias for the most recent commit. So there's a general Git flow that we will use for like when we work locally. But then I'll have everybody actually set up a GitHub account, and then we can actually look at like doing something with that, and you can actually make your first code contribution, and you can also even create your own repositories. So a lot of times companies will actually ask for your GitHub, like when they're looking to hire software developers or people that work with software, because they want to see like what code you've worked on, and they want to kind of take a look and see like what you've contributed to. So generally what you'll do is you'll clone a Git repository and then into as like your working copy. So essentially you pull down somebody else's code. You're going to modify that working copy. You're going to add and edit files. And then, so a lot of times, like maybe if like a week has elapsed and other developers have already committed on top of the branch that you pulled down from, or on top of the commit that you pulled down from, then you might just want to pull down those changes first just to make sure that everything is still okay and that your code still works and there wouldn't be any like merge conflicts, which are an awful thing that you'll have to deal with if you're working with large code bases. Just review the changes. So take a look. Does everything still work? Commit your changes to the local repository. Just check, make sure everything's okay. And once you're sure that everything is okay, you can push your changes to the repository. And that repository will hold that commit the current state of your code base. So let's go ahead and just, I'm gonna show you something here. So assuming that you have you're able to use Git in your terminal, hopefully you can. So I am going to make a directory called, actually I don't need to. All I have to do is type this. So git clone, and then this is a link to a remote repository. And when I'm cloning, essentially what I'm doing is I'm taking the code base that's there, and then I'm cloning it into a new directory called my first repo, which is what that remote directory is called. So I pulled it from here. So, and I can actually, I just realized might be useful if you have that. That's send. Oh, it got cut off. I think I can just send you the link to the repo itself. Yeah. So that's all you do. You just say git clone and then that GitHub URL. This is the code that's currently there. I have already made some commits. And if we take a look at the branch, it's not quite what I'm looking for. I'm actually not like super familiar with GitHub itself. Yeah, here we go. So essentially here's the master branch. So I haven't branched off or anything. So I have one branch, and then essentially we have these three commits that I've made. So the first commit I made, which has this particular tag, and you can also access commits by doing that. So if you want to move back to a commit, then you can just copy this. I made another commit on top of here. I wonder if it shows you what the changes are. No, it just takes you to that version of your code base. Oh well. They're pretty not interesting changes. Oh yeah, here we go. So I made a commit here about an hour ago, and I added a file called helloworld.txt, and then I had a file called, or I added the phrase hello world to there. So we can pull that down. Let me open my terminal again. And if we ls, we're going to see my first repo sitting in there. That's the directory that contains our current code, and it's not really code, it's just files. But so essentially, we're just kind of using a very fancy save function. So if we cd into my first repo, we can look in there, and we have all the files from that remote repository. Hello world.txt, readme.md, something.md. So I'm going to go ahead and actually remove those files. And then if I type, so if I do ls, you'll see that nothing actually shows up. That's because I got rid of everything. If I do git status, it'll show you what my current changes are that are unstaged currently. Yeah, that's why I was worried about the redirect link. Oh well. Maybe I'll just copy paste these commands somewhere else. But but yeah, if you go to the GitHub, like the actual GitHub page, then you can actually go down here to where it says clone or download, and it just gives you the link there to clone. So if you just copy that, which is Command A or Control A, I think, on PCs, then you can just have it there. If you don't want to type it all out, which is understandable. So we have these changes staged for the commit. Basically, we've deleted all these files. I'm going to commit these, and I'll say git commit, or I have to add first. So I'll say to add, you can do it a few different ways. So if you just want to add one file, you would just say git add, and then maybe hello world.txt. Control C. Oh, I actually meant to copy like all of the text in that field, like which is Command A on Macs. But yeah, Control C or Command C would be how you copy. Also, like, just learn keyboard shortcuts as much as you can, and then just get used to using them, because, like, I don't know, eventually people just think you're a wizard, which is neat, because I've always wanted to be a wizard. But it turns out that most of my wizarding involves just knowing keyboard shortcuts. But we have to work with the magical powers that are bestowed upon us and accept what we have. Anyway, I don't know why I said that. That was weird. So if we do git status again after adding hello world.txt, you'll see that we have the staging area, which says deleted hello world .txt, the fact that we deleted it, but then we have these unstaged commits, or I'm sorry, these unstaged files as well. So they're not in the commit yet. If I want to add all of these, a cool way you can do that is just do git and then star.md. Since both of those files end in MD, we're essentially doing a pattern matching. So the star means select all, and then putting .md at the end essentially just says select everything that ends with .md. So we'll say git add star.md, and then if we check the status again, now we have those three files staged for a commit. So now I can type a commit message. So I'll say commit git commit -m, and that lets you just type the message on the command line, which is not usually what you would do. Usually commit messages are pretty long, or I guess it depends like what you're who you're working with. Most commit messages I see are like pretty like a half page long. In this case, we are going to see. We're just going to say git commit deleted all the files. which is generally not. I think if I saw a commit that said git deleted all the files, I'd be really upset for the most part. But in our case, it's just for educational purposes. Oh, so when I say staged or unstaged, this is kind of like this is the simplest visual I think that represents like a GitHub and like a Git environment. So when you're making changes to your code, like what you're working on currently, that's called your working directory. When I said git add and then I added those files, I moved those files to something called a staging area. And once those files are in the staging area, I can say, I'm going to commit this to the local repository. And when I do that, and when I finally commit the code that's in the staging area, it takes all the code in the staging area and puts a new commit in there on top of the previous commit. So basically, whatever you pulled down before, whatever the previous state of your code base was, after you commit your changes, your commit represents the most up-to-date version of your code base that's in your local branch. So the staging area is just where you put, it's like a middleman, it's just where you put files before you commit. And the reason you'd even have that is because, like, I actually ended up doing it by accident, but here, I'm just going to reset. I think that's git reset head. There we go. So yeah, if you do that git reset head, basically this is saying reset the head, which is, if you remember the topmost commit, reset head to be the commit before head. So now essentially we took away our last commit, and it's, we don't, it'll still be there, but like we're not going to be doing it. Or actually, I'm not sure what happens. Yeah, I actually don't know. But basically, like, right now all these files are just in the working directory because they're not staged. And then if we can say git add readme.md, and then if we do git status again, so now readme.md is in the staging area, meaning it's ready to be committed. So if we commit now, reading.md will be in a commit that's put on top of the most recent commit that's in your local repository. But you still have these other files here. So that's why you would have that middle manager, because you might be adding different files as you go along. That's actually not my workflow. That's not how I use Git. I essentially, git add and git commit are usually just done one right after the other for me. But some developers will just be like, okay, let me add that because I know that works, so I'll just put that in there. And then maybe they make some other changes. They add readme2.md for some reason. I don't know why you do that. Then, they're like, oh, I want to include that too. So then they add git readme2.md. And then if you just want to add everything to the staging area before you commit, you can just do git add dot. And then git status will show you, okay, apparently we just renamed something.md to .readme.md. I don't quite understand why that happened, but whatever. And then we'll just commit again, because all our files that we want deleted are in the staging area. So we say git commit -m, deleting all the files. And I would never, ever, if you're working with other people on software, write the phrase deleting all the files in your commit message. I would lose it pretty quickly. So now, if we do git status, you'll see your branch is ahead of origin master, which is where we pulled from. So essentially, like, it's saying your branch is ahead of the remote repository branch commit, the most recent commit, by 1 commit. And it says use git push to publish your local commits. So we have our local changes in the repository, in our local repository, but they're not in GitHub yet. So if we want to do that, we can just say git push, and there we go. So it just goes right back to that repository. So if we go back to our GitHub repository, we have my first repo, and there we go. we just had readme.readme2.md, which is the only new file we created, and we just deleted everything else. And then if we look, we have 4 commits now. And if we click on the commit that we just made, which is where the commit message is deleting all the files, you'll see that we basically just deleted some files. Very, very, very exciting stuff. But let's just create a new file. So I'm going to say touch just hello world.py. We'll make it a Python file. So let's go ahead and just, we'll edit hello world.py in Vim because apparently Echo doesn't work for me. And I'm scared that I'm going to see whatever I saw before because when stuff comes up and I don't know what to do with it, it's really scary. So we're just going to use Vim because at this point I feel okay with Vim. So I'm gonna go ahead and just make a quick Python file. Print hello world. And we'll say if name is equal to main, call main. And then I'll just put some comments up here. Hello world.py. I'll put my name. And then I'll press escape, WQ. And then if we look at get status, we now have an untracked file. It's hello world.py. We haven't used it yet, or we haven't staged it or committed it yet. So let's go ahead and add it. So we say git add hello world.py. Oh, by the way, so really cool on like Linux terminals. I think Ubuntu and everything should do it too. If you say, so let's look at the files I have in this directory. I have readme2.md and then hello world.py. If I want to, for example, look at hello world.py, you would use the cat command, which just prints out the contents of the file. So like, readme2.md, if I cat that, well, there's nothing in it, so that's just unexciting. Let me put something in real quick. Right. Now if I cat readme2.md, you'll see the message hi. That's just what I put in that file. So let's say we want to see what the current contents of hello world.py are. Then we could say cat hello, and all you have to do is type a couple letters, basically enough letters so that the substring that you type is unique enough that cat can find a file that begins with these letters. And in this case, there's only one file that begins with HE, so you can press tab, and then it actually just completes the file for you. Mind blown when somebody showed me that. So yeah, there's our file, just a simple Python file, cat hello world.py. We look at the get status again. So we modified readme2.md, and then we also have hello world.py, which is currently an untracked file. Let's just say we want to add both of them to the staging area, get add dot get status. So we have these changes ready for commit. So we can say git commit -m, adding a couple files like Python hello world. That's our commit message. Look at the status. Our branch is ahead of origin master, which is the remote branch, by 1 commit. So we can just push those local commits. There, better positioning. Sorry about that. So if you go to my first repo, then you'll see these changes. To the ones we just made. So that's like a really, really basic tutorial with Git. It's basically enough to get you started like with a GitHub account and actually putting stuff on a GitHub account. In the chat, can you say whether or not you have a GitHub account? And then if you don't have a GitHub account, I'm actually going to have you just take a few minutes and create one. It just takes a few minutes. You just need an email. And as long as you're okay with giving that email to Microsoft, you're fine. Because Microsoft currently owns GitHub. They bought them like a year ago, I think. So if you have a GitHub account, let me know. If you do not have a GitHub account, let me know. And if anybody doesn't have one, I'll give you guys a few minutes to make an account. Otherwise, I can just keep going. Okay, so at least one person doesn't have a GitHub account, which is enough of a reason to give you guys like 5 minutes to work, and I'll come back in 5 minutes and just see if everybody's up and running. But yeah, so all I want you to do is just go to github.com, and then just make I'll get in a incognito browser so you'll see what it looks like. Incognito, because I want to be sneaky. Okay, so you just sign up. You create a username. You put in an email address, password. They had a really funny CAPTCHA, like to verify that you're not a robot, where you have to rotate animals. It was the first time I've seen this particular CAPTCHA, and it amused me way more than it really had any reason to. I just thought it was kind of funny. Software web applications are becoming really sophisticated at telling whether or not you're a robot. I know if I was a robot, I'd have a really difficult time rotating a cat. Anyway, so just going to go ahead and set a 5-minute timer. And I will let anybody that does not have a GitHub account to set one up for themselves. Oh, that really didn't take long. Okay, never mind then. So no timer, no counter. Cool. All right. So when you're signed into GitHub, you should be able to see your repositories, which you might not actually have yet. So what you can do is you can go to New and just create a new repository. So you can call it whatever you want, but if you want to be consistent with me, just follow along with my naming conventions. So you can put a description in if you want. Just make it public. You can skip everything else, and then initialize this repository with a README though. I'd say do that just because then you'll have something to look at once you pull it down. And then when you create the repository, it'll take you to the repository page. And if you go down to where it says clone or download, this is the link to your particular repository. So I would just copy that link. You can go into your Linux terminal. I'm going to go ahead and just go back to my master folder here, teaching. And then we would say git clone, and then you can just paste the repository link that we just copied from GitHub. When I do that, I will now have a folder called My First Repository. We're in. Successfully, we have hacked the GitHub mainframe. So if we look in here, we have one file, readme.md. I don't think it's going to say anything. Oh, it just has the name of your repository and then the description of your repository. So that's what that does. And then, so let's say we just wanted to make a quick file. So I can say touch some text.txt. I'll just vim it again. Press I, hello world, escape, WQ, or :WQ after the escape. Get status. So now we have that untracked file, some text. We just add some text, git add some text.txt. Check the status. We have all those files ready. We have that one file ready to be committed. We'll commit again. git commit -m. I just wrote some text. Now we're ahead of origin master by 1 commit. So we'll push it. And then if we look at the remote repository, we will see that the file that we just wrote, sometext.txt, is actually there. Very neat. So yeah, like you should just be able to do that yourself. The only difference you might have is if you're making a new Git account, it might just ask you for like your GitHub username and password. But once you do that, it should actually automatically configure for you. If it doesn't automatically configure, just let me know. But these are the real basics of Git, and essentially just having like a remote repository, a local repository that you're working with, and then another remote repository. So does anybody have any questions so far? Since a lot of this stuff is not, I guess it's kind of conceptual. I mean, yeah, does anybody have any questions about the Git or Linux stuff that I went over? Okay, cool. So, and if you do have a question, just let me know. That would be totally fine. So I'm gonna quickly, yeah, I don't want to. I'm gonna. No, we'll just keep going. We can do a couple more things. So right now we only have one branch that we're working on. It's the master branch. So if we type git branch, we're going to see star master, which is essentially saying we have a branch called master, and we have a star. The star next to it says, okay, we're just, this is the branch that we are currently on. Now, let's say we wanted to not work on the master branch, which happens pretty much anytime you make any code changes. So let's say, I just want to make my own code changes, and I don't want to bother other developers. I can say git checkout -b, Chris branch, we'll say. So now if we do git branch, we'll see two different branches. We'll see Chris branch, which is the branch I just created that I also am now on. I have what's called checked out that branch, meaning that I took my working directory and just took it over to this new directory. So, or I'm sorry, the new branch. But if we look, we still have all the same files, and we, if we do git status, we're on branch Chris branch, nothing to commit, working tree clean. So let's say that we want to make another change. So I want to change some text.txt, and haha, I've made changes on another branch. Neo. Morpheus. All right. So now we have that file sometext.txt, and that is unstaged. We can stage it. So we have sometext.txt staged in Chris branch, not in the master branch. So I'm curious if there's any visualization of this on GitHub. I'm actually not sure off the top of my head, because it's honestly been a while since I've really worked with GitHub. So let's say we'll commit this, and we'll say added some matrix script, git status. So nothing to commit, working tree clean, because we just committed. So if we do push, right. So if we're pushing to a remote branch that does not exist yet, so you can always think about your Git repositories. Like there's a local Git repository, which is the one you're working with on your computer, and then there's a remote repository. Usually the local repository is a copy of the remote repository. and then you make changes to your local repository, and then commit those changes to a branch, and then push it on top of the remote repository when you know everything's okay. So the first time you're committing to a branch that doesn't exist yet, you would have to set your upstream. I think there's actually another way to do this that's quicker, but whatever, we'll just follow the commands. So we can do git push set upstream, origin, Chris branch. So this does it does another nice thing where it will actually set up that remote branch for you. So there's actually a lot of architectural stuff going on under the hood that Git actually performs for you, which I think is pretty cool. So you'll actually see you've recently pushed branches, Chris branch less than a minute ago. So now we have an entirely new branch that we're working on. So we actually have two different branches. So we have default branch, and then we have Chris branch. I kind of wish that there was a better visualization of this, and I'm kind of wondering if there's like a plugin, because I find it much easier if I can literally see a tree in front of me. It might actually, I feel like that would actually just make it easier to learn Git. In this case, it just shows you like, here's the master branch, and then here's Chris branch. So Chris branch has everything in the master branch, plus that change we just made. So now let's say we've looked at it and we're just like, this looks fine. I think I'm comfortable with putting this on top of the master branch. The general workflow I would use is something like this. So if we look at our current branch is Chris branch. So we'll check out master. So master just has everything from before, but it doesn't have, it's not going to have that matrix text. It's still going to have like just hello world. It's not going to have any of the other just nonsense that I wrote into the file. So what we can do is we can say, so first generally what you would do is you would say, or what am I trying to do? Oh, I want to merge the other branch into this one. So first what you would do generally is say git pull, and git pull basically pulls all the same, like all of the most recent changes. So anything that you have not pulled directly into your into your Git repository, it's not going to be there. So if another developer had made a change somewhere else, actually anybody else could actually make a commit to that branch right now. And if I did git pull, it's going to pull down those changes into my local repository. So I'm going to do git merge Chris branch. There we go. So that worked the way I expected it to. So basically, we just took the divergence from Chris branch and then just pulled it right back into master. So now if we do git status, my branch is ahead of origin master by 1 commit because we just pulled in the other local repository, the one created for Chris branch, like for that particular, for that branch, that local repository. So now if we push, that pushed to the master branch. So if we look here, my first repository, we have these two branches. And if we go to master, now master will have those changes that we just made. So that's what happens when you merge stuff back. Now, being able to do this intuitively is generally kind of hard for people. It generally takes people a while to get okay with commit or with Git. But if you understand these concepts, this is honestly most of what you'd be using for Git. Now, there are much more complicated concepts like this, and it gets weird when you have to do things like go back to a previous commit, make a change, branch that back off into the master branch, and then merge something else on top of it. It does get complicated, especially when you're working with a lot of people. I work on a lot of repositories I work on have hundreds and hundreds of commits. So going back and finding bugs can be really tedious. That's mostly what you would need to get started with Git. I didn't really understand Git for a while. I found this game really helpful. It's called Learn Git Branching, and it's honestly just pretty fun to play too. So you start off and you have like all these different, so like introduction to Git commits, and it kind of gives you a tutorial and says, a commit is this, Git wants to keep commits lightweight. So it's kind of just showing you like, okay, like let's say we're on the master branch right now. Head is at C1. We say we commit something, and now we have a new commit, C2. So it just wants you to, so if you go to the command line here, right, so what you do is, to use this site, you just click on show goal, and you're essentially trying to get your branch, which is here, to look like the goal, which is in red. So in this case, we could just say, I guess we just type git commit twice. That's pretty boring. So we essentially just made 2 commits. Hooray. So they start off like kind of laughably easy because they're really just kind of showing you the basic concepts. So in this one, they're asking you to create a new branch. And we want to check out new image, and then commit. So let's look at the goal. So the goal is to have a second branch called bug fix. So if you remember, we can do git checkout -b bug fix. Git branch. Oh, I guess it doesn't like. I don't know why it doesn't like that. Oh, okay. So it just wants you to type git branch bug fix, I think. Yeah. Okay. Which I don't know if that actually works. Yeah, I don't know. It's not the syntax I use, but that's the thing about Git. Like, there's a bunch of ways to do the same thing, as there is with a lot of different languages. And then we can check out bug fix, and then that's it. And I'll take a look at one of the harder ones, because a lot of the time the instructions like are less appealing. Like, looking at the instructions is like a little less appealing to me, or when I was doing this was less appealing than just like trying to solve. Yeah, let's do number 4 here. Yeah, so there's another concept called rebasing. And then it basically just takes a bunch of commits from somewhere else and then just puts them somewhere. And so in this case, if we did git rebase master, if the working tree looks like that, then essentially what it'll do is it'll take, like if we're on bug fix and then we rebase we rebase master, it basically takes the commit over here and then just puts it on top of C2. So it's a little bit like committing, but like slightly different. And the thing that's cool about it is that it lets you actually, like, it keeps your working tree a bit cleaner, because it makes it look like you developed like features and put the commits in a certain order. So you're not seeing like another branch just come over. So if we do get rebase bug fix here, it's going to take, so okay, in this case, you were checked out in the master branch, you've rebased onto bug fix. So let's see what the goal is. Yeah, so they just end up getting more complicated. I mean, I'm not just trying to stream myself doing this game. It's I just kind of want to show you how it works. Accidentally clicked a button on my mouse. Oh yeah, I think the one thing I didn't like about this game is that you kept having to click through the tutorial or the instructions when I just kind of wanted to see the goal most of the time. So, so in this case, we have master, and we don't have the branch bug fix yet. So, so what we can do is we can say get branch bug fix. We'll check out bug fix so that we're currently working on the tree bug fix. We'll commit something on bug fix, so we'll have that C2. Now we will check out master. So we want to go back to master. We'll commit here. So now we have C3, and then we can rebase. So we can say get rebase bug fix. I did it backwards. Okay. Okay. So the way you're actually supposed to do that, because I'm not sure how to just like reset it real quick, but maybe this will work. Yeah, I'm not gonna worry about it. But like the yeah, that's the basic idea with this game. You just use the terminal. And then you can just like solve. I'm wondering if there's just like a way to. Oh yeah, we can just reset. Cool. But yeah, I would actually recommend trying these out. I actually found this really helpful when I was trying to learn Git, because for a while the branching concepts just seemed kind of foreign to me, and I had a really tough time understanding them intuitively. So this particular application I thought really helped me. Oh man, I did the wrong thing again. Okay, you're gonna watch me solve this once, and then I swear I am done. So we'll check out bug fix, we'll commit, create commit C2, check out master, get commit, and then we'll check out bug fix, and then rebase on top of master. So it moves C2 there, and then that level is complete. So in addition to just like maybe watching this again or trying this out yourself, making your own GitHub repository, and then working with both local and the remote repository, and then just playing around with this a little bit, I think it should really get you started in a way where you can start feeling a bit more comfortable with Git. Just in general, I think I'm gonna end it here and let you just play around with this. I would also recommend doing Coding Bat. Essentially, I have a lot of people catching up, like in the class that are watching the videos just asynchronously. So I'm trying not to rush too much. But if anybody has any questions, I'd still be happy to answer them here. So does anybody have any questions about the Linux or the Git stuff? Cool. So hopefully that was useful to everybody. If you have any other questions and you're still having trouble with Git or anything else, just let me know, and I'm happy to just help you one-on-one as well. Yeah, send me a message in that case. Otherwise, like I said, hopefully that was helpful, and have a good night.